Okay, maybe we'll start now. We'll be on time. People are gonna keep on arriving. So welcome again. Hello, everyone. This is the Autolume workshop, and I'm really happy to join everyone today from beautiful Vancouver. We're on the west coast of North America, on the unceded territories of the Coast Salish people. And today I am joined with Arshia Soban, who is a PhD candidate working at the Meta Creation Lab, Lionel Ringerbar, and Michael Kokrowa-Doyo, who are both research assistants and everyone is an artist here at the Meta Creation Lab. And I'm Philippe Pasquier. I'm the director of the Meta Creation Lab, and I'm a faculty at the School for Interactive Art at Simon Fraser University. So today we're going to present Autolume, and this is a little bit of the plan of the presentation for today. I'm gonna give some introductory notes, put things in context, in quite a lot of details actually, and give you a little bit of the vision behind Autolume and go through the motivations for the tool and its various features. Then Asha will present an introduction to GANs. Asha, do you want to say hello since we're in this introductory round?
For sure. Good morning, everyone. Really happy to have you all here and excited for this new workshop on Autolume.
Awesome. And I forgot to say we are recorded, everyone, so that you know. Then we'll have an Autolume hands-on, and then we'll start with a module on data preparation and training with Michael. Michael, do you want to say a few words to everyone?
Yeah, hello everyone. My name's Michael, and yeah, excited to be here, and we'll see how it goes.
And then Lionel, who is our main developer at the moment on the project. It's an open source project, so anyone is welcome to contribute or consider doing so. He's gonna do a hands-on demo with going through the various features we have, focusing on generation and control of that generation. Then we'll have a quick conclusion, and then unless there's burning question or technical issues as we go, we will ask you with all your question maybe for the end, and we'll have a Q&A. That way we'll be able to post the recording uh, and and um and you won't have necessarily to be in it. Perfect. So with that, if there's no question, I'm gonna get started. So this workshop is part of a series that we are inaugurating this year, where we bring together a number of tools that have been developed at the Meta Creation Lab or in collaboration with lab members across the years. And we feel that it's a good way to make those tools known, but also to defend the vision that come with those tools, which is quite an alternative to the dominant discourse that is being served by the corporate world and the media around AI, and maybe a way to disarm or to help introducing nuance against an increased polarization around the topic of using AI for creative tasks. And that polarization is easy to understand and very rational, but there is diversity in AI tools like in anything else, and we want to make that known as much as we can. We think it's healthy. And so there's 4 workshops. Yesterday we had the first workshop on computer-assisted composition with MIDI-GPT, with a hands-on in Reaper with our new MIDI-GPT plugin. Today we're looking at Autolume for visual generation. Tomorrow we have guest presenters, a guest of the lab these days, Misag Azimi, who is going to present Fragmenta, which is a way to, again, personalize model or train your own LoRa or fine-tune your own Stable Audio 3 clean model and do text to audio generation. And then we'll finish Saturday morning for the Braves out there with Ahmed, who will present our Comfy UI objects for model bending of diffusion model, how to get inside the model and really appropriate ourselves and use it as a material that we can artistically work with. All right. So in way of introduction, when we talk about creative AI, we talk about AI. And when I mean AI, I don't mean machines that are sentient and that are going to take over the world. I just mean the idea of automating using computers tasks that would take human intelligence otherwise. And in that sense, AI is already everywhere. It's specific, task by task, different algorithms, different AI are being used. But that's what we mean. And at the Meta Creation Lab, we're really focusing on creative AI. So this idea of automating and looking at the automation of tasks for which there's no optimal solution, which typically are creative tasks. And we do that across domain. We've been active for since 2008 here in Vancouver. And the way we do it is through research creation synergies. We make scientific research, we publish algorithms, we evaluate them, working with the industry sometime to do so. And then eventually we develop our own tools, design and develop our own tools and open source software. And that's why these workshops are about, is to present some of these and get your feedback and onboard new users to those tools. We do that often in collaboration with artists because we believe in participatory design, this idea that if artists are involved even in the making of those algorithms, then we're going to get different types of tools coming out of the work. And so that's our methodology, and we make art ourselves, and we work with artists as well as we do that. So we are facing now, in general, a new wave of a rise of generative AI in every domain, and creative domain are no exception. We're moving in a way from AI as content recommendation. You search something on a search engine, and you get links served to you. To AI as content generation, where you search something on a search engine and you get the answer directly that is coming from those links. So there's really a big paradigm shift here. And since 2020, 2022, there's been really a rise of creative tools that typically revolve around prompting. They live online, they're big models, and then you prompt them to generate content. In a sense, this is nothing new. And yesterday I was presenting Audio Metaphor, which is one of the early prompt-based projects that we developed at the Meta Creation Lab that allows to automate sound design and query a system to get a number of sound files and a timeline and a mix for them. So this is not quite new. And we even been studying those type of interfaces. And the problem is that prompting works for some, and good things can be done with it, but it also has a lot of issues. And one of the issues that we've been showing in the research at the bottom here is that we find, whether you're beginners or professional, especially for beginners that are not domain expert, when you use prompting, you don't feel, it might be great work you generate, but you don't feel it's your work. And so there's a lack of authorship, and so a lack of authenticity in the function of artistic expression, which is to being able to express yourself and to feel connected with the content of the work, of course. And so we find in our research that with prompting, you don't get necessarily to be the author. And everyone has been prompting here, in, I'm sure, some big models, and you get an image or you get a music for sure, but is it your music? Is it a collaboration with the machine? Is it you just driving that machine and the machine did the work? Or how much authorship can you really claim? And in fact, this problem with prompting, and that's why we're interested in alternative to prompting to control generation, has been criticized by many. And an issue as well with prompting is the last mile problem, this idea that you get things that are maybe pretty good, but you never exactly get what you want. And today with Autolume, we'll see that with other control mechanisms than prompting, things like direct manipulation, which we have in Autolume, you can eventually hone in with more precision on some content that you like. In fact, a lot of those systems that are available and pushed by the corporate for us are not just a bit problematic in terms of authenticity of the creation, but literally in legal terms, because in Canada and in the United States, for example, and in most legislation, simply prompting And AI does not grant you authorship or copyright ownership over the generated output. And so since we're in a workshop for visual generation for artists, it's really important to know that things are easily becoming quite complicated when you actually use prompting in your practice. With all those big models that live online with those interfaces, there's also a lot of legal issues and ethical issues around big data. Allegedly, a lot of those models are trained on possibly copyrighted content, and there's an ongoing series for the last 3-4 years of lawsuits. Some of them have settled, some of them are still ongoing. A lot of the company are claiming using fair deal um, uh, uh, in scrapping the internet to get data, but typically the legal system is trying to protect creators and artists and data providers in that sense, and it seems that it's a mixed bag of results, where there's some wins and some falls. The problem with creative AI is also the rise of synthetic media and synthetic content that we see there, and the abuse that some do of those systems, where there's people flooding literally some platform with generated music, generative visuals. I have a friend who is a painter who was trying to find a portrait online. It was like, I can't find a portrait that is not AI modified anymore. It's hard to find. So in the consequence of this general set of issues that comes with the dominant type of systems that are out there and that people are really familiar with. We have those big corporations that are stealing data without consent, pushing systems that are sold as being omnipotent and potentially replacing most of us by taking our work. And so, of course, people aren't happy. And there's a real polarization within the creative industries, but really within most industries at the moment around AI, and a lot of pushback. And so that's sort of very understandable. And I usually empathize with most of the reason why people are pushing back, of course. But what people usually miss is that instead of rejecting completely AI, we would be better to gain awareness of the diversity of AI that there is, because the truth is we need a bit more nuance than no AI or all AI, because it won't be no AI and it won't be all AI either. And we need to decide what AI do we want, in which context. There's also a variety of AI in terms of socio-ethical settings. We work on open source free software that are funded by public funding, since the lab belongs to Simon Fraser University as an institution for the most part, or by the volunteer work of people contributing to our project. And we push a vision in which AI doesn't have to be even privately driven. It can be it can be a public service. And there's this notion of AI common that I'll come back to during the conclusion. So there's a real diversity of options there beyond just the corporate solutions. And then there's a diversity of types of AI, where it doesn't start nor end with big neural network that require large data centers and have to suck all of the data out there. And so to these types of problems, there's solutions, and some solutions does not preclude, or the solution that can be employed where we still stick with a big data approach. And there's a lot of consent mechanisms that are possible. Some companies do well by retributing the artists and the creators, often not enough. But there is possibility there. And then there's a lot of public domain data, Creative Commons. We talked about it yesterday when we talked about the various type of license with MIDI GPT. But today we want to focus on introducing Autolume, and therefore I want to start by presenting the notions of small data and model crafting. And here I'm going to borrow some slides kindly given to me by Ahmed Buzurek. And so there's 3 ways of generating that we can really think about in meta creation, where you make a model or you get a model and you navigate it. So you generate element by navigating a model. You can also take a model and modify the model. So fine-tuning, LoRa's, change the model, personalize the model that you can then navigate. Or you can train and craft a model from scratch. Constitute your own data set or find a data set and then train a model, modify the data set because the model maybe was not doing exactly what you wanted, and then iterate that way. And that's what we call model crafting, this idea that you can integrate the making of the model as part of your practice. And that's very much going to be the ethos for Autolume. And if we look at the options out there, there's, of course, all sorts of corporate approaches where you can use existing models, but we saw that there's issues with prompting, there's issues with the ethics of those models. There's very specific models like GANs that are available, online interfaces that allow you to navigate this model, web-based user interfaces for stable diffusion. And then if you want to run things locally, there's also some diffusion model you can program, graphic programming in Comfy UI, but it's quite technical to get there. Automatic 111, it may be an alternative that is online, that is free, and that can also run locally, and that would be for diffusion model. So that has a graphic interface, and I recommend it if you're a beginner in visual generation. It's a good place to start. If you're more intermediate or expert, you know MaxMSP, you know a little bit how to program with objects, things like that, or maybe Touch Designer, then Comfy UI is a great tool. And here I had a slide, we'll share our slides where the two are compared. With Autolume, we're going to look at GANs, not at diffusion models. And Arshia will introduce GANs to you right after. With all of one of the very desirable things in terms of the specification we're looking at to motivate Autolume is to run things locally. And then that works, but it's hard to generate with those models on a CPU. The inference will be slow, so typically you need a GPU. That's where NVIDIA makes money on all of us, but that way you don't have to use the cloud. But you can also use the cloud, a more private cloud where you run your own virtual machine and rent, in a way, a GPU there. So there's ways to do things without necessarily using the service of big giant or big corporation. So those are ways to navigate existing model. When it comes to adapting models, it becomes more complicated and more technical. There is Playform, but this Runway ML, but you are your tribute of those platforms maintaining those features. And we have a lot of horror stories of artists giving the data to the cloud and either losing the data or getting the data stolen or losing their model in the middle of the production because this feature was removed. So there's danger here, and everything happens in the cloud unless you're a really great programmer and you know Python and you can program your way through. And then the third option is to craft a model. And there, if you want to craft a model, develop and design new types of model or train existing types of model, then you sort of have to be technical and program. And that's where with Autolume, with the first and the only tool that we know that would run locally and allow you to craft models without a line of code ready. And so that's really what the software is about. So if we look at the specification of Autolume, or if we just listening to them across the years, listen to artist desiderata, to what type of AI they want, what type of AI we want. Well, in fact, we don't really want to just navigate big model trains on everyone else's data. We want to be able to navigate, adapt, and craft our own models. We don't have trillions of images, so we want to be able to work and constitute and manipulate small data sets. Small here can be dozens of images, hundreds of images, but it can also be thousands, hundreds of thousands, or millions. Small, small in the field of AI is different than small in common terminology. So your computer locally can handle already a lot of data, but not big data in the data center sense. We don't trust necessarily the cloud. We want sovereign compute. We want to run things locally. We might be on stage. We might be performing. We don't want necessarily to be connected to the internet. We don't want to learn Python. Artists, painters, photographers don't want to become computer scientists. And if possible, we want the system to run in real time and to allow for direct manipulation. And of course, it's better if it's free and open source. And if you look at this set of specification, which doesn't sound like a crazy request, then there's exactly 0 tool that allow you to do that right now. And so that's why we made Autolume in the first place. And so Autolume is our neural visual synthesizer. And both Michael and Lionel will present to you and demo to you all the features we have. It allows you to, of course, create data set, train your own model, and then navigate this model with a lot of funny features. And it does allow for direct manipulation, this idea that you can really manipulate in real time the parameters of the model and really manipulate it as a material to find the sweet spots that are so very hard to find if you use prompting as a way to navigate. So there's been a lot of artworks made with Autolume. I have a small selection here. There's a section on the Autolume website where more of them are being presented. And so I encourage you to have a look there. We started with Jonas Crash, which is the original developer and with whom I first envisioned Autolume, and we did the first design pass on it, and we did some work training the model on some of our data sets. We've been collaborating a lot with artists because that gives us a lot of feedback and helping them training models on their work. For example, Erika Lapada Jensen here in Vancouver is a media artist doing a lot of collage and colorful artworks, and we've been training several models with her work that have been exhibited. Arshia, who will present right after me and introduce GAN, is a calligrapher himself, is interested in Arabic calligraphy. And here I'll take the opportunity to say that one thing that is important with model crafting is not that we want to just avoid big data and not touch any stolen data, or we are in principle against big data. It's also because those big models train on everything tends to average stuff to Western culture or to some, and they have issues capturing the nuances of specific cultures, especially the ones that are not dominant in the data distribution, what we call the long tail of the data distribution, where you have all those cultures that are not as represented on the internet as others, and cultures or elements for which there's a lot of biased data. And Arabic calligraphy falls into those two categories, where there's not that much of it online, and what's online would be Indiana Jones movies with fake Arabic calligraphy. Or here, for example, on the left, some paintings from the 19th century by white painters for white audiences that didn't care giving justice to the Arabic calligraphy and would hallucinate, invent characters. And so therefore, if you ask a big model like DALL-E on the right side here, as Arshia shows in our publication at SIGGRAPH in 2024, you ask for Arabic calligraphy. It's beautiful, but it's pretty, but it is not Arabic calligraphy, and those characters don't exist, which is kind of insulting. In other words, what I'm saying here is small data and model crafting is not just a position, is that sometimes to get to the type of content you want to generate and make a model of, you have to train your own model. There is no other choice because the big models won't do it. So it's not just being renegade here, it's really also very practically needed. We've been collaborating with Arshia on a piece called Ensemble that is exploiting one of the model Arshia trained on the data set that he constituted. We had in 2024 an Autolume exhibition at Ars Electronica. We were really happy to present a collection of work, some of the one I just discussed here in Linz, in Austria for Ars Electronica. And then there's performances made with Autolume. Arshia has a performance called Reprising Elements with Joshua Rodenberg that is live calligraphy and then interaction with Autolume. There's interactive installation that are possible. We've been working with Lionel will present as well today on an installation, for example, by which we can take pictures of audience members, and then we can find their face into a face model, and eventually we could make them smile, for example, using a deformation of their mouth, for example. So interactive installation of that kind. And I've been using it on stage as well with my collective Cafe with Kian Lee and VG Amagi. And as I'm arriving to the conclusion of my introduction here, I'll play a short excerpt of here Autolume is being fed to Touch Designer, and this is a bit of audio reactive content. I'll play this excerpt. All right, a little palette cleanser for the ears here. And that's me for this introduction here. And so with that, I'll pass it on to Asha, who is going to get you closer to the system by looking a little bit at what is powering Autolume. Asha?
Thanks, Philippe. Let me quickly share my screen. Can you see it in full screen now?
Yep.
Perfect. Okay. Hello, everyone. Hello again. I will give a very brief introduction into generative adversarial networks, or GANs, as the type of generative algorithm that we are using in Autolume. As Philippe talked about, this notion of AI as being one thing is really not true, and we all know that. And there are some very interesting architectures that predate the current mainstream text-based generative AI systems, GAN, one of them, which has shown to have huge creative potentials. I'm just going to give very basic idea of what GANs are and some of the fundamental ideas behind them, so that it would hopefully help with the system demo and some of the concepts that we discuss over there. All right, I would say it's pretty safe to assume that we all are familiar with the current state of text-to-image generative AI systems. And the main idea behind these systems is, as Philippe outlined in detail, is that these systems are designed and trained based on big data sets, really huge data sets. And the very basic idea behind them is to generate everything. And we already know that everything is not really everything, but that's the idea behind them. Another fundamental idea behind them is that the generation happens through conditioning. So the very basic form is that we give it a text prompt, we ask what we want, we condition the generation based on that text prompt, or in some cases, we can combine that with image prompt as well. Generative adversarial networks, or GANs, are a type of generative AI algorithm that predate text-to-image models. And the idea behind them is fundamentally different. So in comparison to what we consider big data, GANs are trained on small data sets. And these data sets are often, at least based on what GANs were initially designed for, are meant to represent one visual domain. I often use the example of dog images because why not? They're cute. And now if we have a data set of dog faces and we train a GAN on that data set, the trained GAN will be able to generate new images of dogs that in a way don't exist, meaning that they don't belong to the data set. It's not simply copying images, it's extracting the visual patterns, generalizing those patterns, and creating new instances of the same visual domain. So this idea of capturing the visual patterns and creating new instances is the foundation of what we call unconditional generation, meaning that we are not giving it a text prompt, we are not conditioning the generation, but we are creating new instances of a certain visual domain that we have in our data set. It's represented by the data set. Very briefly on how GANs work and how they are trained. The idea is that during the training time, we have a data set that represents the visual domain, in this case, dog faces, and there are two neural networks that are working in parallel and in competition with each other. We have a network that is acting as a generator, and its job is to generate new images. And at first, when we start the training, it knows nothing. So it's generating kind of noisy images because it has not learned anything yet. It has not extracted patterns. We also have a discriminator whose job is to look at what comes out of the generator and decide whether or not this is a generated image or is it from the data set. So it's kind of policing the generation and decides based on that, the generator tries to become better and better to create images closer to that visual domain so that the discriminator has a harder time figuring out whether or not it's generated or it's coming from the data set. Throughout this adversary algorithm, we will eventually get to a point that the generator becomes really good at generating images that looks closer to the original domain. And then the discriminator will be somehow 50-50 because it's now really close and it cannot really confidently say whether or not it's generated or comes from the data set. When we are done with this training phase, what we are left with is just the generator. That's what we need and we will use. In our case, that really tangibly, it is a file that sits on our computers. It's the .pkl extension, or what we call the pickle file sometimes, and that's the trained model, which basically contains all the weights and biases of that generator, that neural network as the generator. And that's what we'll keep and we will use for the generation and navigation. One of the fundamental ideas and concepts in working with GANs is the understanding of the latent space. So mathematically speaking, this latent space is a hyperdimensional space that kind of represents the space of possibilities that is created during that training. So when we say we are doing unconditional generation, one way to look at it is that now we have constructed this mathematical space or computational space, and each point in that space represents a generated image. Of course, imagining a hyperdimensional space is really tricky. We can only imagine 3D spaces, but I find this analogy to a 3D space, an imaginary 3D space, really helpful because we can now imagine a point A in this space, and if we pick that point, it corresponds to an image of a dog in the case of dog faces that we're discussing. If we now take another point B, it corresponds to a different dog face for us. And we can just keep sampling, and it will just construct this massive space of all possible dog faces that this trained model can generate. A unique feature of GANs is that this latent space is smooth, meaning that points in the vicinity of each other correspond to similar images. And this smoothness allows us to move from one point to another point kind of seamlessly and staying in that visual domain all the time. So no matter how we move in the space, we are kind of swimming or floating in this space of dog faces in this case, or any other visual domain that we have trained the model based on. Another idea, at least behind the type of GANs that we are discussing here, we are using in Autolume, is that this process of the generator becoming better and better, and at the same time the discriminator getting better and better in this training process, is that we start from generating, the network starts from generating lower resolution images, and eventually goes all the way up to the intended resolution. Throughout this process, it extracts different levels of visual features. So, for example, in the case of human faces, if we have a data set that represents human faces, there are certain features that are kind of more fundamental. For example, an oval shape in the center of the frame kind of represents the overall shape of a human face. And then we get to facial elements, then we get to things like texture and all the fine texture on the skin, the hair, everything. So throughout this progression, the network captures first coarse features, then somehow middle level features, and towards the end, when we get to higher resolutions, it starts capturing finer details. This idea of feature hierarchy and how GANs extract these feature hierarchies into different layers is a very powerful tool that we kind of we have access to in Autolume by having access to different layers and applying different transformations and different possibilities that Lionel and Michael will show during the system demo. And this becomes this powerful tool to create very unique aesthetics. Well, as I mentioned, GANs predate the current state of text-to-image generation. The first network was what the basic idea of GANs by Ian Goodfellow was created in 2014. And now that we look back, it's kind of funny to see how we were excited about that kind of fidelity in image generation. But that was a huge breakthrough at the point from network architectures like visual autoencoders. And throughout the years, by 2018, StyleGAN was introduced, which was a network by NVIDIA, and it got really close to the idea of photorealistic image generation. And now we have like StyleGAN kept evolving till 2021 with StyleGAN 3, and things got better and better. Certain artifacts were addressed and issues were resolved. So this, from a more technical side, this idea of getting more photorealistic and the photorealistic image generation has been very interesting and kind of like gave an agenda for researchers. You might have come across this website, thispersondoesnotexist.com, which I know people freaked out over how photorealistic images were, and these are people who don't really exist because these are generated images. And the idea behind GANs kind of promises that these are not copies from the data set, these are just new generations, new instances. But this is one way of going and approaching GANs, and it kind of depends on how big your data set is within the small paradigm. And how long you let it train, how much computational power you have available. Another way of approaching it is when you have a data set that is either smaller or more diverse, or you train it kind of in a shorter period of time or stop the training kind of prematurely. And an artifact or a visual feature, I should say, of this kind of generation is something that sometimes is called visual indeterminacy. And if you look at these two examples, at first you think you're seeing something, but the closer you look, you don't really see anything in them. So there are certain levels of visual features extracted, but not all of them. And it represents a very interesting visual quality that has been used in the creative applications of GANs a lot. There have been early adopters of GANs in artistic practice. Some of the great artists who have used GANs with very different approaches. An example of a more technical approach is Mario Kleinman, who, by manipulating the network itself, by changing the algorithm towards a certain aesthetics, have created very unique visual features in his work. Another example is Anna Ridler, um, who has um, who has presented more conceptual focus on the dataset part of how dataset is created and what that conceptually represents, and then harnessing all the visual qualities of GAN in representing that. And then an artist like Helena Serene, who treats GANs very differently and sees herself more as a curator in this process and this creative practice, and does a lot of premature training and collages after that with the generated result, as opposed to just having the final generation as the artwork. Well, as I mentioned, NVIDIA's style GAN family of GANs have been a kind of a benchmark for GAN quality. NVIDIA has been pioneering in this 2018 with style GAN, and then I think 2019 with style GAN 2, which was a major improvement in terms of quality, and then style GAN 2 ADA. Which ADA stands for Adaptive Discriminator Augmentation, but the idea is that they kind of created this method of training GANs with even smaller data sets. So they enabled getting closer to photorealistic image generation with a smaller data set, as small as, for example, 1,000 or 500. But of course, that is for the photorealistic image generation. This is the network architecture that we first adopted for Autolume, and we have been working on top of that, and now we have more advanced features, and we now have even support for StyleGAN 3 in Autolume. But that is kind of the basic idea of now we can train GANs with small data set, and that's kind of fills the gap for artists who may not have thousands of images of the same visual domain or same artistic practice of their own or their curation, but maybe they have hundreds of data samples. Okay, to wrap up, these are kind of the interesting things about GANs as opposed to the current text-to-image systems. The idea that we can train on small data sets in which the artist has a lot of agency and authorship over how data is created, where data comes from, and how they make sense of data. There are unique aesthetics to GANs, some dominant visual aesthetics, and some that can be harnessed based on the practice of or the artistic practice. The idea that generation happens through navigation and exploration, and it's not conditional, has shown to be a major strength point in the sense that prompting has shown to kind of limit certain creative intentions, or in some cases in our user study, it has shown to be a more intuitive way of interacting with the generative system. GANs are generally lighter and faster than most text-to-image generative systems. That's why with Autolume and on a gaming laptop, we can reach over 30 frames per second, which allows more real-time generation possibilities. And the fact that the latent space of the GANs is smooth, so this navigation and that direct manipulation becomes even stronger. Okay, with that, I'll wrap it up and I will pass it over to Michael and Lionel for the full system demo.
Awesome. Thanks, Arshia. So yeah, let's go on to the demo itself now. Share my screen right here. And I'm gonna paste this website link to Autolume's GitHub page. And we'll get started on how you can easily download Autolume right now. So you can just go to our GitHub page, Autolume right here, and you can scroll down. You can go to Releases tab, or you can scroll all the way down here, click this link, and it'll bring you here, scroll all the way down again. And yeah, there you can find the download files that you need according to the OS that you have. So let's say you have a Mac, you can download this one right here. There's Linux there, and also Windows. So what you can do is just download it and then open it, follow the steps, and you're good to go. Cool. Now let's go to Autolume itself. Now, before anything, I would like to show you guys about our documentation that we have, which you can access here. If you click it, it'll bring you to Autolume's documentation page, where if you have any like difficulties or any questions, pretty much you'll be able to find it right there, and including like all the modules are there as well. Cool. Now, Autolume consists of these four modules. And the main tree that builds up Autolume's workflow is the prepare, train, and perform module. How it works is you first prepare your data, and then you'll get data set from that. From that data set, you're going to put in training. And then later on, after you train, you get a model, which you'll put in perform. So that's how Autolume works. Now let's get started on preparing the data. And yeah, if you have like any difficulties on any of the elements that you're confused of, you can hover above the help features. It'll show you like a brief description of what it is, and if you click on the help, it'll bring you to our documentation according to what it is about. Now let's start off with importing an image data set. I'm gonna import this data set right here, which comprises pictures of space. And how you do it is just import images, select the data set, and press OK. Automatically, it'll bring you here into the thumbnail section, so you can see like the data. I would highly recommend that you guys use the prepare module right here, because style GAN training have like specific requirements for the data set. Two most important, I would say, is that the image should be square, so width and height should be the same, and also the resolution should be a power of 2. So for advanced users, of course, you can prepare the data set yourself elsewhere, but for newer users, it's better to use the prepare module, because that way it'll ensure that your data set is good for training. So yeah, let's move on to the parameters itself. Resize mode, there's two options, stretch and center crop. So yeah, you can play around with that. Resolution is pretty straightforward. It determines the size of your final model later on when training. And I'm gonna give you guys an example right here for the non-square framing. So what happened? So let's say you have this image right here. Since we need a square image, and then the resolution is 512 by 512, the picture gets cropped. And let's say you want to like preserve the image as it is. You can do so by enabling the non-square framing. That way the image will pretty much stay as it is. But what happens is just it's gonna add paddings. And you can you can control the aspect ratio by yeah, clicking buttons right here, and you can also change the padding colors right here. So yeah, just play around with the parameters according to the data set that you have. Now let's move on to augmentation. Here we have two options, which are X flip and Y flip. X flip flips all the images that you have imported left to right. Y flip upside down. And this applies to every single image that you import right here. So let's say if I enable the XFlip right here, it's not you're not really going to see anything right now, but later on when you process the data set, you're going to end up with double the images that you have because every single image is being flipped left to right. So you're going to end up with 414 images. So yeah, that's pretty much it about with the data prep module. And yeah, let's go on to process the data set. So you can choose the folder name, put space, save path. By default, it's going to be here in your user preference directory that you chose right here. You can move it elsewhere. Let's say I want to put it on desktop. Sure. Okay. Now that's everything done. We can process it. Now you can see right here that processing part, there's going to be 414 images. We're going to have that in the end because we enabled the XFlip. So that's that. And yeah, just for the sake of this demo, I'm going to stop it right here. And I'm going to show you what we just created. So the image is 512 by 512 as specified right here. And you're going to see the augmented image right beside it. So it is mirrored left to right. And it does it for every single image right here.
And the mirroring is really just a way to get more data if we're fine with those symmetries. For example, if I take a video of myself making faces and I train a model on all those frames, then I don't want a vertical flip because that would mess up the model. You know, faces, the eyes are supposed to be at the top and the mouth at the bottom. Arshia, when he trains models for calligraphy, then he don't want the horizontal flip because characters don't work in both directions. But if you train a model of textures, of pictures of skin or whatever you feel like, whatever your material is, sometimes it's good to augment the data. And in this case, Michael, I think that's a good example of a case where when you look at the sky, you can flip things, and unless you care about the star formations themselves, and you just care about the general appearance, then that would work well to augment the data set and generating a little bit more data so that the model get more of a chance to converge when we train it. And I'll let you continue, Michael.
Yeah. Cool. Now that we have our data set, we can move on to training. Yeah, just click up here, brings you to the train module. And yeah, again, if you have like if you have any difficulties or anything, like you're not sure about what these are, you can hover above the help. All information right there. And if you want to know more, you can just click it right here. Cool. Let's start with the training. SafePad is pretty self-explanatory. It's gonna save all like training progress right there. Yeah, by default, it's gonna be there on the user preference folder. So that's that. We have this resume option right here, which allows you to resume training, and I'll get back to it later. Dataset path. This is the dataset. You're gonna specify your dataset here, and it'll be trained based on that. And then, which I'll do right here. So I've prepared a dataset, 8 by 8 resolution, the exact same dataset that we just created. But yeah, for the sake of time, I'm going to use this smaller resolution dataset. So it's now loaded. And then we have these two right here, training augmentation and augmentation pipeline. This is what Arshia mentioned before, the Stallion ADA, where right now with training augmentation, it allows us to train models on smaller data set. So we can train models on thousands of images instead of 100,000. So yeah, that's great. And I would say the ideal size of data set is 1,000. 500 would be minimum, and usually like around 100 would not really be a great idea. And then yeah, there's augmentation pipeline as well, which I would recommend to like leave it as default right now. But if you want to know more, go ahead to the documentation and there's like a complete guide about it. Batch size. Batch size determines like how many images that you want to be processed at a time. And I would say this is pretty important because it depends on the dataset resolution and also the amount of VRAM that you have. Let's say right now I have a 24 gigabytes VRAM GPU and I'm training 1024 by 1024 model around 1,000 images. I would recommend batch size to be 4 because I find like that's like the most that's like the safest option for training because too big of a batch size means it will take up more VRAM and to the point where you don't have any like VRAM storage left and basically training just gets stuck. So yeah, that's batch size. And we have configuration right here, StyleGAN 2, and recently based on our recent update, we now support StyleGAN 3 and T and R. So that's that. And we also have our advanced options. I would keep the generator learning rate and discriminator learning rate default. And if you want to play with anything, play with gamma. Now, gamma is really important to training because it really affects how your model will look like. Let's say if you once you train a model, you don't really like how it looks. You can multiply the gamma by 4. So let's say you want to start off with gamma 4. If you don't like the result, multiply by 4, go 16, and then so on and so forth until you find like until like you're really satisfied with the model that you're gonna have. And then number 6, I'm gonna show you guys this later, but I'm gonna set it to 1. And then there's mirror right here. Mirror is basically similar to the prepare modules augmentation, but instead of actually creating the actual augmented images that you see right here, it's gonna happen inside the memory. So let's say you already have a 5,000 images that is pre-prepared already, and you don't want to like, go back into the prepare module again and do the augmentation. You can do it right here, and it'll not create like actual images on your disk. It will happen all in memory. So it's very efficient and yeah, same thing, X flip, Y flip, and you can do both X and Y. Cool, now let's start training. It's first going to validate your data set. Once it's good to go, it'll go straight to training. And if there's like any errors, like you said, let's say you have any invalid data, it's going to show up and tell you what error you have. So right now training is initiated, and I'm going to show you guys the what you can see inside the training folder.
And then here, let me say a few things, Michael. So you see everyone, the first sample of fake imagery. So that's what the discriminator is going to try to discriminate versus your data set. This looks nothing like the data set, normal, because the neural networks are sort of initialized with sort of random content. And then eventually it means the discriminator is going to get it wrong sometimes, and definitely the generator is generating rarely wrong a lot of the time. And so there's going to be error calculated, and that error will be taken into account to change the weights in those neural networks, adjust the weights so that next time, if they were presented with the same image, the discriminator would not make that mistake. And for the generator, next time it will generate images that are more likely to fool the discriminator. And you go through all the data to calculate those errors using each time the batch size, and you accumulate the error on that batch size before you change the network. That's what the batch size really does. And then eventually the mathematics and reality show that if you do that adjustment and passes through the data with those errors and you adjust the weights, if you do that, doing that is called an epoch. If you do it on all of the data, then if you do that enough time, we're talking hundreds, thousands, millions of times, then the weights of the network are going to converge, if the learning goes well, towards really good generation and towards this smooth, continuous latent space that represents the domain the visual domain of your data and that you can then navigate. So that's what training is. And here we start it, and now we will have to decide when do we decide to stop it, because it's also a process that sometime will never really end. Yes, Michael, I'll give it back to you.
Yeah, cool. So yeah, now training is started, and this is the folder that where it's gonna hold like all the training runs that you're gonna do. So yeah, I'll briefly explain what each of this is. So the fakes is basically what you're seeing on the UI right now. And then these snapshots right here is the model that you're gonna have. This is the model, this is the thing that where you're gonna plug inside the perform module. And then the reels is the real images. You cannot really see much. Matter of fact, actually I'm just gonna show you this right here, since I would say it's a lot better. So yeah, this is the real image that I have. So this is like another data set I was working on. These are the real images, and this is the progress of the generator. So it starts out with these weird stuff. Eventually, it'll start to be a lot better. And yeah, those are the basically if you want to see your training progress, you see it based on the fakes because it really shows you yeah that's how you know if you're good enough or not for training. And
And in fact, this is, Michael, this is a subjective decision, and one that with Autolume, we made the choice to sort of give all of the decision power, expose all of the parameters to the user, and give the decision power. Often when you use a model, an AI model, you're not the one training it, and you're not the one deciding when the model is good enough. Here you really have that, and so that's why we save those models along the way. The ones at the beginning, they're not been learning a lot, so the first few snapshots, the pickle files that Michael is pointing at are not learning a lot. And then as you move forward to the training, the visual content is going to get closer to the data. But you might want, as an artist, and you might find it prettier if it actually doesn't get to realism, if it doesn't get to exactly the data distribution. And so that's one of the decision that you have to make. And so we save everything along the way. Go ahead, Michael.
yeah, so that's training, and yeah, I'm gonna go back to the resume option. So this is especially useful if you're gonna do long training. Let's say you have a 1024 by 1024 data set. It's gonna take a while until like the model actually gets good. And you might, let's say, because it's gonna be taking like so much VRAM, you might want to, let's say, do training only at night. So when you sleep, it's training, but when you're up, you want to do work and those stuff. Now, resume is going to be your best friend because you're going to be able to show you right here. So these are the model files that we just created. So the last one was 20 pickle. Just I'm gonna refer to that. Oh, 24 actually. So and then it'll automatically select the data set based on where this model is trained, and yeah, you can just start training again. So it will start to train where you last left off. So yeah,
And so
just
this is an amazing feature, and one that is really central to the idea of model crafting. Not just because, yes, sometimes you want to stop the training, use your computer for something else, use your GPU for something else, and come back to it later, like Michael just explained, but also because of fine-tuning. Fine-tuning is this idea where you take a model that has already been trained, maybe on a lot of data, and we give access, you'll see that later, to a collection of models to you. And with fine-tuning, you have a base model, and then you have a smaller data set, and you're gonna take that base model that, for example, know all of the faces, and then give that model pictures of your face, and then eventually fine-tune a general face model with small data on a more specific visual domain. Instead of the domain of all the faces, you want a latent space with just a particular face in it. And talking about faces, I wanted to give credit here because it's a collaboration we have. Michael just showed a snippet of the dataset that Alexandra Dulik at UBC Okanagan, who is a great visual artist. We collaborate with her, and that was just I wanted to give credit here where it belongs. That was the examples of her artwork here, some of the data we're working with. So yeah, fine-tuning is really also using the resume option there when you load an existing model, but also curriculum building. Think of those models as a little agent that you teach, and you might want to teach first a model on faces of cats, and then you say, well, this is interesting, but it's not crazy enough. I have those paintings of abstract textures that I made. Let me now take that cat model and throw a different data set and fine tune it and see what happens. So exploring the space of possible models, or then starting with cats and then introducing dogs and see what happens. So you have the possibility here to stop the training at any time and in a way change the data set and then continue the training. Not something that you can do with any of the tool online, obviously, but with Autolume, you really have that level of control. And that's what we mean by model crafting, because the truth is when you start using Autolume for your art, you will find that your first model is likely not going to be your best model. And this idea of model crafting is that you have to iterate on the making of those models, which is, of course, propelled by the making of those data sets. And so that's really where the resume feature here is important, not just to just resume the training, but also to do fine-tuning and to do curriculum training and curriculum changes. Back to you, Michael.
Yeah, and yeah, one more thing that I forgot. The number of ticks between snapshots. So basically what happens is right now I set it to 1. So every 4,000 images processed, it's gonna dump the fakes and also a model. So let's say you don't want you don't want it to be this frequent because it takes up quite some space. You can just increase it to like 4. Usually it's 4, or if you're like really confident on what it's gonna look like, you can again increase it all the way to 8. That way you can save space and yeah, I would say like that's pretty much about the training. And now on to Leona with the perform module.
Hello, everyone. So now let's jump to the performance part of Autolume. You've trained your model for hours, and now you would like to perform with it. So I will demonstrate how you do this inside Autolume. Okay, can you see my screen now? Visible?
Yep.
Okay, great. So we were in the train module. So now moving to the perform module. Once you trained a model, it should be in your training run folder. It's like a Autolume data folder. It goes training run unless you changed it to something else. If you left it in the default model, then you can load a model by clicking in the network and latent section. You can click on models, and it will automatically show here in the lower section, which is where the training runs are. And you can see and load all the different snapshots at different moment of training. So you can load an earlier one or a later one, depending on what you want. Here I'm going to start with loading a model that we trained on Dahlia images from iNaturalist, which are Creative Commons license images. And I'm going to demonstrate the first 2 sections of Autolume, which is the display and capture and network latent. So here you can see I loaded the 1024 images. So the first thing is that you can also click on fit to show it as a higher resolution image. Of course, it doesn't invent pixel. It actually just stretches the 1024 to whatever is your screen resolution. It's just for you to have a better view of what it is. If you go back to raw scale, you can see the image is smaller. We also have an actual model, another model that's for upscaling images. So if you click on super resolution, it will actually allow you to quadruple the resolution. And now it's kind of inventing pixels using another AI model to be able for you to have a higher resolution. Though you need to be mindful that because we're adding another level of processing over this will also use more GPU, so it won't be able to generate images as fast. So I will disable it for now. You also have a full screen module, which allows you to have your image, like have the image in a separate window. You also have a screenshot function that allows you to take a screenshot of whatever image is currently on screen, and a record button. So record button, if you click it, it will start recording what's on the image on the screen. And when you click stop, it will dump a video into the Autolume data folder as well, into captures folder. So that's for a screenshot and record. Now, let's start with the navigation. As Arshia talked about latent space navigation earlier, there's multiple ways do we get to navigate. Here we offer like the seed mode, which basically it goes through a certain way of navigation of the latent space. One way you can navigate, you can either click on the screen here and you can drag to navigate with your mouse. You can drag on two different axes, on the left to right and up to down, to get different images, and that allows you to navigate manually the latent space. It's kind of like a manual way. As you can see on the left side here, it changed the seed. As you go left to right, it will go to the next seed, to the next seed. It's a way for you to also remember when you find the space that you like in seed mode to go back to it. We also have a button that's for animating. So it will animate automatically from left to right through the seed. And you can also control the speed at which it goes. So you can go faster if you want. You can go backward as well to go back the other way. So that's like the way you can navigate the seed space. And there's also another mode of navigation, which is called the vector mode. And in this one, you cannot click and drag or tell it I want this seed or this seed, because vector space works differently, but you can animate it as well. And also this something interesting is that the navigation in general, the automatic navigation and animation in the two space will give you a different feeling of the transition. It's really hard to explain. I think it's better if you play with it, and you'll see when you animate in seed mode and in vector mode, you will have a very different kind of feeling of the transition. For example, on that model, it feels sometimes you go faster and slower and faster and slower with vector mode, whereas with the seed mode is very, very smooth. So it can be interesting, for example, for flowers. You can also, instead of using seed, you can randomize. So it will generate a random vector in the latent space for you to be able to explore it. And with vector also, the way you don't have a seed, so you can type something to go back to a certain space, but we offer something is that, for example, if you find a dahlia that you like, let's say this one, you can save the vector on disk. Here I'll put it on my desktop. And so if you navigate and go elsewhere, eventually you can browse to load it again to find, again, that spot in the latent space. And so here I am back to the initial dahlia that I had. So that's for the network and latent section. Now I will introduce the diversity and noise. Diversity and noise is a setting that allows you to look through the space in a different way. For example, diversity allows you to, as it say, sort of increase the diversity of the model. So if I animate, for example, here, and I bring down the diversity close to 0, you will see that basically the image stops moving, even though it's animating, because it's gonna pick kind of really the most average of all the images the generator can produce. And if you increase diversity, then it will be able to start producing more diverse output. And as you go higher, it will be able to produce more and more diversity. Usually the sweet spot in Autolume by default is 0.8. 0.7 to 0.8 is actually usually a good spot. If you go too high, it might actually produce output that are less realistic and a little bit more crazy. So it also gives you good controls for creative outputs.
Yeah, and then Lionel, if I may, If you remember the latent space, Arshia was representing it as a cube. In fact, it's multidimensional, and we're moving randomly here in that latent space. And when you touch the diversity, think about the data distribution being all those actual images that you fed that are somewhere inside that latent space, and then the cube around it. And the diversity is a little bit like how big that cube can be, because this latent space is actually bigger than your data distribution. It goes to infinite in every direction. And so you can, with any sort of GAN model, stay within the distribution a little bit, and then you will recognize, in this case, the flowers, or you can add the diversity, or later on we will see go further in certain directions in the latent space and move out of distribution to go into the abstract. And eventually every latent space has sort of this sort of structure whereby the data distribution is in a way in the center, and then you can extrapolate in any direction outside of that distribution in that smooth, continuous latent space. And with that, I'll give it back to you, Lionel.
Thank you, Philippe. Now going to the noise. Noise by default is 1. What it does, it allows you to to balance between noisy and smooth kind of output. So noise being 0 by 1 at 0 by default doesn't influence the output at all. But if I bring it closer to 0, you'll see that the image becomes very smooth. So if you have that's also again like a creative power that it gives you on your output and how to control it. It can be very interesting to go from one to the other. And if I go all the way up, then you'll see like a more grainy, more texturally defined output. So going back to like, let's say, put it to a higher level. There's also an animation mode you can use there, which again, this can feel very like shaky, but that's also again another control that you may be interested to use. For example, if you use on phase model, you can see the air sort of like move in all directions. I'll load one to demonstrate that. Or even the freckles on the face, or different face feature gets very animated all of a sudden, and very smooth, very textury, nice. All right. I'll stay on that model for now. Now I will demonstrate another way of navigating a latent space. I'll bring back noise to set it to 1. Okay. Looping. So right now we saw that we could navigate through seeds and so vectors in a sort of a random way, not a way that we get to control, but we also offer a looping mode. And the looping mode, what it does, it has 2 modes. It has a keyframe mode, where you can define here by default, you get 6 keyframes, which are defined to seeds 0, 1, 2, 3, 4, 5. And what this means is that now if I'm going to remove 3 of them and leave 3. If I loop it, it will actually go from seed 1 to seed 2 to seed 3, back to seed 1 to seed 2 to seed 3. It allows you to define your own loop in the latent space. Now I can define my own. I'm going to find like a couple different face. Say I would like to have this face. You can click snap on the first keyframe here, and it will actually pick that position and assign it to the keyframe. If I continue navigating, those glasses, I snap the second keyframe, and now I go to yet another place, and I will snap to that keyframe. Now when I click loop, you'll see that those 3 places that I found in latent space can be looped in a continuous loop. So that's for using the keyframe mode. You also have different ways you can control how the timing of the loop. Either you can use a time mode. So here I define by default is defined that the loop is 4 seconds, but I can slow it down that way. Or you can use the speed mode, which instead is based on arbitrary speed for you to control. So it's not dependent on the number of keyframes, because if you have a certain number of keyframes and you say, I want this loop to be 6 seconds, and all of a sudden you had more keyframes to the list, then everything's going to slow down. So if you don't want this to slow down, then you can switch to speed mode so that it's constant regardless of the number of keyframes. So that's for the keyframe mode of the looping widget. Now we're gonna look at the noise loop mode. The noise loop, you have to imagine some kind of circle going through the latent space. It's a random circle that's going across dimensions in latent space. And this one is as a size of a radius of 1. And that noise loop navigates through it. So if you have a noise loop of 1, the loop will come back through to the start pretty fast. But if I define it, I'm gonna go in speed mode because it's a bit more, it's easier for noise loop. If I define a radius of 10, then that noise loop will have a much longer path, and therefore, like the loop that it will produce will take much longer to go through. One thing notable as well by this mode is that the way the transition happens in the output is very different than the other mode, the keyframe mode. You can see, for example, there's like very fast transition that happens at times, very quick, instead of like the keyframe mode usually is a bit more of a smooth transition. So that's also can be an interesting thing to play on for your creative output. And perfect loop mode is if you want to record a video, for example, and if you go to keyframe mode, you go back to the start, you click perfect loop. It will basically what it does is that it will execute the loop from the start and will stop at the end. So if you record a video, it allows you to be able to record a video that loops perfectly from start to end. That was for the looping mode.
Yeah, and then on the looping mode, some people use Autolume because it's a real-time visual synthesizer. We'll talk about frame rate and computers a little bit later. Use it for VJing and to do audio reactive pieces. And then often in music and in VJing, in visual for music, you get this balance between repetition and diversity and novelty. And loops, in that case, of course, are really useful. That's one of the use of the looping module that has been popular.
Mm-hmm. And there's also an aspect to this looping module, which is being able to send OSC message to synchronize beats with music, for example, a certain performance. But I will keep OSC for the end of this presentation, which was also you to control all those knobs and switches in the UI externally. No, performance in OSC, actually, we're talking about OSC quickly here, is just something that tells you how fast the rendering is happening. So depending on your hardware, you'll get more or less fast. Here I get 40 FPS. On certain models, I can get up to 50 FPS with my hardware. If you go to a lower resolution model, I'll get more FPS, frame per second. So it's how many images it's able to generate every second. So if you have a lower FPS, it means that it will have a slower output. And one thing, I'll get back to this one later because it does have some aspect around like OSC and outputs for sending the video to another software, for example.
And maybe now is a good time as well to say, since we talk about frame rate, because we didn't really mention it. So you get the version for macOS, for Linux, and for Windows. But if you want to train and really generate at video speed, right now it's mostly the Windows version with NVIDIA GPUs that will work best for everyone, and the Mac version we're working on it, but it works well, but the frame rate would be quite a bit lower and training would be almost impossible if not for very small models. And so that's one of the barrier to accessibility still of Autolume and of running things locally, is that you need quite a bit of compute really do that. Now those local GPUs are really into every gaming machine, and the gaming is extremely popular. So if you know any teenager around you, you might be able to get your hand on one of those machines that way. Back to you, Lionel.
Yeah, definitely macOS is a work in progress, but some chips are getting better and better from the M1 to M5. If you have like M1 Max, you can get up to 20 FPS on very good on large models, so it's still pretty decent, but not as fast. The good news is if you want to record videos, the record mode always goes 60 FPS, so you will still be able to produce a smooth video that will not be real time, but you'll still be able to produce a smooth video if that's what you're looking for to use for. And talking about resolution and models, I forgot to mention something early on in the network and latent mode. The model selector, we do provide a selection of curated models with Autolume. You can click here at the bottom. There's a download models function, and that's how you will access the screen with a pop-up. We'll show you all the models that we created. So here you'll find a mix of models from other artists that we have curated. You have the specific license when it was provided, unprovided, and also a bunch of like NVIDIA produced models, which are pretty good quality and good reference in general, and others that we provide from other artists that are more abstract. And we provide also, I added this morning the Dahlia model in 64 resolution. So if you are on a lesser, like a GPU that's not that powerful, then you'll still be able to run this, probably even on just a CPU. So it's very pixelated, as you can see, but you can still see what the Dahlia generation model looks like at a certain speed here. So if that's something that you want to try. And so everything is in download models here. Going to a feature mixer, and we'll load now a face model, 1024, to demonstrate the feature mixer. So as Arshia mentioned earlier, the way that images are generated in GANs is from resolution from lower resolution to higher resolution. So at first the model would generate a 4x4, like 4x4 image or 8x8, I'm not sure. 4x4 and then 8x8, 16x16, little by one by one. And something we can do is that we extract automatically in Autolume. When you load the model, the first thing you'll see in Feature Mixer will start doing some kind of extraction. You don't have to worry about it. It finishes within 10 to 20 seconds, depending on your hardware. But what it does is that it tries to find meaningful direction into that space. So it creates for you a slider that will control specific feature in the model. So it could be, for example, whether it will find that some images have long hair and some images have short hair, or some images have people looking to the right, some images have people looking to the left. And this is becoming like a more specific direction in the space that you can use through this feature mixer. By default, it will extract 64 directions. The first ones are the more meaningful. When you get to the 64, it will do not a lot of difference in how you modify it. And you can choose also to which resolution those features apply. By default, it's on all. So if I select this one, you can see that a lot of things are changing in the image at once. If you go really close to 3, you can see it goes a little crazy, but it changes everything in the image. You can change the color, you can change the form, you can change the texture of the image. What we offer is a way to select per zones. So if you select form, for example, it will only apply to layers 4x4, 8x8, and 16x16. What happens then is that instead of changing the entire image, it really just changed the form of the image. The texture of the skin stays relatively the same, or the background stays relatively the same. You can also pick texture, for example, and so now the general form of the face in the image stays the same, but it changes just the texture in the image. So that gives you a very fine grain control on certain specific aspect of an image. The color will select, like, for example, you can see skin color is changed. If you navigate elsewhere, you can see change the color of the shirt, for example, here. A little bit of the eye as well. The lips can change it sometimes. And you can select another feature, for example. Let's see what this one does here. It changes, so like the form, I can have people look left and right just based on that. If I move a little bit further in the model, it's kind of consistent. I can also move it left to right. And maybe if we are lucky here, maybe we can find, well, changes the eye direction of the eye now in this case. Sometimes I'm able to find also like here, for example, I think we get a case where maybe we can give long hair or short hair. So it's something that you really need to play with and explore to really see all the options that this offers. And it's really specific per model. Like it doesn't necessarily translate from a model to a model. So you have to explore those features. And there's another way also to explore directions in those different features. There is a random mode, which instead of finding a meaningful direction that is bound to a certain aspect of the image, you can take a completely random direction in space. And so the output of this can be really wild, as you can see here, like a little bit crazy, yeah? So again, we did this so that you can have full creative output and that you can decide for yourself what works for you. You can pick something very specific or something a little bit more abstract, like here. So that's it for the feature mixer. And we offer 8 by default that you can pick from. Now going to layer transformation. This one is a bit more, probably the most advanced feature of Autolume. And it's something that allows you to add a transformation or noise on a per layer basis. So we talked about like the different layer of generation. If I apply, for example, I click on the 8 by 8 layer and I'm going to apply noise to see what happens. And that's going to create some sort of form deformation here. So depending on the layer that you apply, you may affect more like the form, more the texture of the image, or more its color or other features of the image. So I can apply some noise on this layer. Another transformation you can apply is a rotation. For example, if I apply rotation on this one, I can go to rotate here, click on drag. So you can see that it rotates the face. So that gives you a certain control, again, another granular control on the image other than the feature that we saw. And you can also aggregate all those features together. So you're not limited to just do layer transformation. You can also use the feature mixer to affect that and combine them. And you can see in the UI here that we have little indicators to indicate whether we have a noise transformation or a noise applied to a certain layer or a transformation applied per layer.
Yeah. And technically, what we do here is called network bending. And so there's this idea that, and very few tools allow you to do that. And certainly with direct manipulation in real time, I think we are the only one. The idea is that the terminology is borrowed to a practice in electronic music whereby and in electronics in general called circuit bending, whereby the artist intervene directly on the electronic circuits as an artwork. Sometime in music, it means opening a synthesizer and then putting your hands into water and then making short circuits in the synthesizer circuits to make weird sounds. Here, in a way, we access the inner guts of the neural network of the generator. At the top, it's a deterministic neural network. If you give it a particular seed, and that's why we can memorize the seed and retrieve an image that way, or a particular vector, in fact, that is generated from that seed, those are the two modes, then from that seed, it will generate the first 4x4 image and then go through the network to generate whatever resolution you want. And then now we can intervene on the weight directly. By doing those multiplication, those translation, those transformation on those weights. And when we mean weights, they're literally just numbers. And in fact, the matrix of numbers of the size indicated there, but as you know, because they're pixels, there's also different channels for colors and things like that. But they're typically matrix of numbers. And so we can manipulate those numbers. And that's what network bending is. And that's what the layer transformation module really allows to do. And what we see here is also what Arshia was describing, that the layers at the top of the hierarchy, they're looking at the general structure of the image and very, very coarse aspects. While if you go to layers with much, much more weights, they're closer to the final resolution, and they typically correspond to finer grain and textural features of the image. And so you can really decide at what level of the visual space you intervene when you make those transformations.
I would
to
also
Lionel.
add sorry, Lionel, before you continue, I would add just a little point here about how many of these features are really discovered by experimentation, and it really depends on the model that you are loading up. We oftentimes use this face model because it's a little bit less suggestive in terms of artistic applications. Also, it allows us to really very clearly show if there are like distortions or changes, because we are very sensitive to that visual domain, which might have a different meaning or visual interpretation when you're loading up a more abstract artistic model that we already have preloaded over there, and it might not be as clear as seeing human faces, but sometimes in applying those effects we get to some creepy spaces. But again, I'm just suggesting that you need to experiment with these on their own terms with the models that you load up. Over to you, Lionel.
Thank you. Yeah, and I just loaded the Dahlia image model with the same transformation to see how that affects and how it's different from applying to a face model. The experimenting is the key here. Layer transformation. So that was the simple layers. There's also an advanced mode to give you like more the intermediate layer of the intermediate layers. But I will not go through this one and just encourage you to experiment with this and do your own research to, if you really want to understand what you're doing into this one, to figure out what's happening in those, because there's a lot to go through, as you can see. I'll just like reload that. Now to go to model mixing. Model mixing allows you to mix the weights of two models at once. And so, for example, I'm going to load again is the free GAN 512 or 1024? I'm not sure.
You can use either. It's best for model mixing to match the resolution, but even if you don't, it automatically deactivates the latest layer of the higher resolution model.
Okay, so it's a 1024. Okay, so I will load a face model, for example, here, and start animating slowly this one. And what I will do is that I will use another model that we free again, which is a bit more. Actually, I will show first what it looks like. So again, is more abstract output here. So it has this kind of aspect to it. What we were trying to do is to bring some of that aspect into a face model. So I'll load the face model and then I'll load free again. And what I'll do is I'll start applying it to the lower resolution, where I will use this, like this layer from free again into that image. And we can see that as I start applying some of the colors and aspects and form and texture from that model starts sort of appearing in the face model. So that's another kind of creative output that you can use to mix different models. It's not a very precise tool, like in terms of control. So it's very important, again, to experiment, and you get to have more level of granularity here on how you want to apply it. So I think this one is a good example of how we can mix a more realistic model with a more abstract model. So you could be training your own abstract model on existing models to kind of create more variety in outputs.
Yes, that's really another example of great tool for model crafting, whereby you get to mix different models. This is sometimes referred to as model blending. So I was talking about model banding just before, where we get into the model and we band the circuitry there, and that's more model blending. And so once you've been training a number of your models, you might want to explore intersections. And you see what's happening here. It's not the general paradigm of AI trying to replicate the data, imitate the data, and make fakes of the data, but more really a creative tool by which often for artists, it's about not getting to the data and what we call sometimes divergent training or divergent generation, where you want to mess around with the model and make it yours, to reach certain aesthetic properties and reactivity. And then we learn with Lionel how to control it interactively. And then all of a sudden, it's your data, it's your model. There's no doubt it's your art coming out. And then you feel this empowered sense of authorship and control. At least this is a hope here, in contrast to some other approach to AI. Back to you, Lionel, for the model blending, model mixing, as we call it.
So that was it about model mixing here. Now I'll talk about the next module, which is presets. As you can see, we've seen a lot of different settings, lots of knobs and switches in Autolume. So how the question sometimes comes is like, I have created all these settings. I don't want to lose them when I leave Autolume. The response to this is the preset module here, where you get to name a preset. For example, say you like this model that you've loaded and you've had set different keyframes in particular that you liked about that model. How to reset it quickly is by saving it as a new preset, and then you can load it again. So I will, for example, if I load this one, audio reactive wiki art. Oops. Nope, it's not gonna happen. Got a little issue here. Oh yeah, I changed directory. So okay, I'll recreate it. That's okay. So I will open a wiki art, for example. Not sure what's going on here.
Live bug discovery. Very nice.
I can't even tell what's
The
going on.
presets are really important. For example, when Vijay Amagi works with Autolume in our show, then we have different section of the show, and he's going to basically go through a list of presets, preparing the different scene and going through them, because then that allows to switch from one model to another like that, and all of the aesthetic changes. So to make brutal changes, visual changes that way. Lionel.
So here I loaded my preset, which had wiki art as a model preloaded. So you can see now it's preloaded, and you can see also some settings have been restored. So I bound here I use I'm introducing two modules at once because it's more practical right now. It's like the audio module as well that's inside. It allows you to capture audio that's happening on your computer, such as your microphone. So if I pick my microphone here and enable, you can see that it's being able to pick up the audio level, the bass, the mids, and the highs, and also the onset when something happens. So there's nothing, and you can change the sensitivity for the onset. It allows you to trigger certain things. And as you can see right now, the visuals are reacting to my voice. And this creates internal messages inside Autolume on audio level, audio bass, audio mid, audio high, audio onset. And in the menu that you can see on each of the modules, there is something called OSC menu. And you can, for example, here, animation is bound to onset. You can see animation only starts when it starts hearing something new. The speed of animation is based on the bass. So the speed at which like the latent space is being navigated is going to be based on the bass of my voice right now. Maybe the bass is not the best, so I will use the mids, and maybe it will go a little bit faster. And diversity is also being controlled by the mids at the moment. So that's why you kind of see it like change through diversity all the time, is because it's detecting through my voice. So that's for preset. And here you can see that if I come back to here, and I enable the audio input, I can reload all those settings very quickly by just loading my preset. So I don't have to rebind all these things. And also, like, the preset remembers where you stopped in latent space. So now we're back at where I was at the start here. So that's for presets. Now I will talk about OSC, because that's a very important aspect in performance in general. Autolume can do a lot on itself, but if you're going to perform, sometimes you may want to connect it to other input from outside Autolume. You may want to bring in a device such as this one, which is a MIDI keyboard, MIDI device, which produce like, so it could be also a keyboard, like that instrument keyboard that you can connect to a computer. So this one, I bound all the different knobs and buttons that I have here into another software called Touch Designer. So don't be too intimidated by what you see here, but here I am gonna move like my sliders, and you can see that it's changing those values. And so that allows me to transform that value into a value that goes to Autolume. At the end, it's going as a OSC message. OSC is a way to communicate between devices and software for audio performance in general. It's a very common standard, and Autolume supports it by default, and Touch Designer is very aware of it.
And the basics of OSC is that it allows you to send numbers from one way to another. So your controller can send numbers to Touch Designer, and Touch Designer will send the numbers to control some of the parameters in Autolume. And there's a very simple system of address, which is basically each of those channels, you give it a name, and that name is now associated with that number, a little bit like that becomes like a variable. And so that's the basics, yes, of OSC.
Mm-hmm. Thank you, Philippe. So here I rename, for example, the channel that was named like this as from the device to speed. So I can remember what is this bound, what does it mean for the final output. And here, if I control speed, I can control the speed from my keyboard, the diversity, the noise. I can enable, disable animation. I can control the different features that I have also in screen. And now I'm going to demonstrate how to bind this in Autolume. Also very important, in the OSC screen here, it says a network port. So it says to which network port, to which destination or which device it needs to go. And Autolume by default listens to port 1338. So you don't need to remember this because it's actually displayed in the performance and OSC. It says 1338 here. So if you don't remember, you need to go there. If you open multiple Autolume, then each Autolume will have its own port. So you'll have to look into which one you want to control. Now I will demonstrate how to bind these controls that I have in Touch Designer in Autolume.
Yeah, and the fact that OSC works over the network like that is really convenient because it can be different software within your computer talking to each other, but it can also be a sensor somewhere else, a computer on the other side of the planet, or just an installation where a computer is making the sound, another one is making the visual, and they're just talking and controlling each other that way.
Okay.
So that's an advantage of OSC really for making different parts of a larger project talk to each other in real time.
Thank you, Philippe. So now I will use the Dahlia model to bind OSC. So first I want to control the animation. So I will go to Anim, use OSC, and then I'll find my value here. So this detects automatically when you send OSC to the right port. And Touch Designer, for example, Autolume will show you automatically, so you don't have to type it. So Anim, and now if I push my button on my keyboard here, you can see that it starts animating. And I can toggle it on and toggle it off. So I'll leave it on. And now I want to bind the diversity, the speed. I want to control the speed. of animation. So I go to speed, and now I can change the speed, make it very slow, go one way, or go backward, go forward, go backward, go slow. Okay. Now I want to control the diversity, the speed diversity. Because now I can make it very, very average or more diverse, or actually too like very crazy in that way. And noise, I will demonstrate noise. Noise, I can make it very noisy or very smooth, like that. I can control the speed. And also sometimes if you don't have a MIDI keyboard, something you can still download Touch Designer. By the way, Touch Designer is a free software by default, unless you want to use it commercially for high resolution outputs. But by default, you could install it today and use it. And one tool also that you can use if you don't have a keyboard is there is a frequency generator, which is called the LFO here. And it kind of like goes from -1 to 1, it continuously does that at a certain frequency. And so you can use this, for example, for controlling the speed. I created the LFO.
Yeah, and since you're at it, and if you don't have a controller, so you can control Autolume with your mouse, of course, with the graphic interface, and all that you can do with your mouse, you can also do with OSC, so with a controller or with any sort of other program. As Lionel mentioned a few options, but I wanted to mention there's a lot of free apps as well on the phone where you can have faders on your phone and control that you can then map using OSC directly to Autolume and control that. You can also use the sensors in your phone, like the gyrometer, the accelerometer, or maybe those are sensors on a dancer that are controlling Autolume. So you see here with this idea of control that you can play Autolume with a controller or with your mouse, or you can use it as a synthesizer, as a visual synthesizer that is live and controlled by any parameter in any sort of new media, interactive art setting. So that's really makes Autolume like a module, a visual module with all of those knobs that you can turn manually and operate manually, or operate through those mappings that Lionel is explaining right now.
Mm-hmm. Yeah, I really like to think about Autolume as a visual synthesizer, as you described it. It's like a tool for, instead of making music or sound, it produces images as if, so you could control it completely from like a regular music keyboard and control Autolume that way to generate visuals. So to demonstrate, like if you don't have a keyboard, you can use certain frequency generators. And so this one, for example, oscillates from -1 to 1. And here I simply bound it to the speed. So it goes very fast and then it goes very slow. It goes backward and it goes, so it kind of oscillates between the same images. Kind of a different way of making a loop in a way.
Yeah.
Without having a keyboard.
An alternative to Touch Designer that I like to mention is Châtaigne. I'll post a link in the chat in a second, which is also great and is an OSC sequencer. So here you can have even a timeline where you actually make a composition and you change presets automatically, and you have you can do a composition, and that timeline might work with a sound timeline or some other videos or some other events in your installation, and you can really control completely Autolume as you would do when you compose music and you prepare things for more fixed media sort of version. So there's really, thanks to OSC, there's really all those different software that you can, ecosystem of software that already exists that you can put around Autolume. And again, Autolume becomes just this synthesis module. Back to you, Lionel.
Thank you. Yes, and there is some interesting software that I use on iOS. It's called, I'll see if we can see it. It's called Data OSC, and it has lots of different options for, like, my background is gonna not show it every time. Okay. But you can control, like, use the compass of your phone, the motion of your phone. You can even use the face or the shape of your face, if you're smiling, you're not smiling, where your eye is it open, is it closed, to actually control Autolume as well with OSC. So that's another way to do it. And here I'm going to demonstrate also, I have this GAN OSC preset. I set all the presets in there, and now I have control on all different aspects of it. I even bound the features here. You can see all the red ones are animate control, so I can stop the animation. I can control the feature 1, feature 2, and stop it, and control like texture, the color, yeah, and also like have a random direction for more control, and all through OSC and the preset together, so I can have a performance ready to go. I think, yeah, so that's pretty much it for the perform module. Now I will just go through the tools. It's gonna be very quick because there's not a lot that to demonstrate today. In this section, you'll see the projection, the super resolution, and the model mixing. Eventually, we will integrate all those tools directly where they need to be in the perform tool or in the data preparation tool. Super resolution would be if you have images for preparing for your data set. Let's say you have 512 images in 500 pixel, but 500 pixel, but you want to train a 1024 models, you could use a super resolution to upscale those images. Of course, like depending on the type of image, you will lose some quality, but it works pretty well on faces, for example, or anything that with texture. So that will allow you to upscale all these images, and now you can actually train on a higher resolution. Though that knowing that this will probably lose some not be the same quality as if you train in a native format, native resolution. The model mixing is similar to the live model mixing that you see, except that you can save it into a file. And so then you can just load a single file instead of doing model mixing live. And this will have like fixed layer mixing. And the projection is the one I want to demonstrate today. Projection is because those these face images, for example, or the Dahlia model has been trained on real images. One thing you could do is to try to find, for example, I'm gonna try to find my face in the face model of that NVIDIA trained. I don't exist in their model. At least I don't think I do. I'll pick this one, and we'll save it. You have to pick a safe path in projection. And there is an important setting here, is the number of steps. So it's how long it's going to try to find the vector that corresponds to your face and can generate your face in that model. So yes, 1,000 is a bit much, I find. So 300 is good. And that's, by the way, when Philippe talked about the Alpha Prism installation that we made where we could project the faces audience in the model and create a loop which morphs between all the members of the audience who was using that tool. So here I'm going to click project. And okay, now we can see on the left side. On the right side is the image I'm looking for, and on the left side is what it's found so far through vectors that it found that looks like the image on the right in the face model from NVIDIA. So that face on the right side definitely is not in the face model, but yet it's able to get, because there's such a diversity in the data set that it was trained on. I think the face model from NVIDIA had 70,000 images as a reference. That's a lot. That's a really big data set. We definitely don't need that many to get something. And you can do it over and over because there is a seed, so there's some randomness in finding it. Let's look at the actual result.
Yeah, because the way it does is a gradient descent into the space where it's looking roughly at a direction where we get a little bit closer if we go in the latent space in that direction. And so it's randomly sampling directions. And so you always get a different path there. And the fact that it will go somewhere is because this latent space is continuous. And so somewhere, something close to what you feed is in. I was surprised you got the background right.
Yeah, you got the background right, but interestingly, earlier I tried and it did get the smile, but it didn't get it this time. But if I was to retry, eventually we'd be able to find something maybe closer or further.
You should try to project into the cat face model or something like that. So
Okay.
there's fun to be out there.
Yeah,
Yes.
well, Lionel does that because there was a question in the chat about the face model. I just posted a link to the data set behind this face model. This is the face model that came with StyleGAN 2 model from NVIDIA. So NVIDIA trained it. And the data set is from Flickr. It has some diversity in terms of representation, but it's certainly biased towards certain things because it's only 70,000 faces. It's a lot, but still it's only 70,000. And it's biased towards, for example, faces smiling. So you won't see much crying or frowning in the data because it's Flickr. People post happy faces. So it all comes back to the data set and how it's collected. But it would be a good foundation for fine tuning based on faces that could represent completely different distribution and diversity of representations.
Yeah, and fine tuning again is this idea that you would take an existing model that has seen a lot of face, and now you would focus on, this series of masks that I have pictures of that I really like, and that I took those pictures and I want to use that. Yeah, Lionel, anything else on your side?
Yeah, just a couple of things still. So yeah, that was the projection into the wild animal model. So as you can see, since there is no like human faces in there, it doesn't really find it, but it does this kind of weird mix of a lion with my face. And that was the result with the other one here when projecting the face model. I'll demonstrate quickly. I took like images from Arshia, me and Philippe to try to project them and get vectors and to demonstrate how a loop can be created that way. Here I already created a preset. So you would use the keyframes mode and would add as many keyframes that you want to project and click on seed to go to vector, click on browse and load the vector to load that vector in the keyframe. But here I already done it into a preset. There we go. And so now I can see like it's going through our three faces and it's kind of figured out where the closest similarity existed in the face model.
I'm gonna get nightmares.
Yes, me too. Okay, and yeah, I wanted to also like talk about the Dahlia model that I created just to show a little bit. So that was the data set here, and there was 499 images for this one, up to almost 500. And all the images were downloaded uh, as license free from iNaturalist. So iNaturalist is a website that I use a lot for getting this because what's nice is that they have a very huge data set of very specific similarity because it will be organized by taxonomy of plants and flora and fauna, so mushrooms or plants and even like little animals that you find in the woods. They will be there, and then you can use this because some of them have also all the images have a license offered with it. So some people will say that's my copyright, so you would not be able to use it legally. But a lot of them are Creative Commons. So I download all the Creative Commons images of Dahlia in this case, and I looked the ones that were pretty large size. I cropped them properly, made sure there was no watermarks or like hands, for example, in the images. And I came up with these 500 images. And after many hours of training, was able to get to that model. For the model training in 64 by 64, it was pretty quick. It can be done within a day with the proper GPU.
And that's something really, really comforting and empowering I find in having that level of control and knowing exactly what comes into that model and nothing else. So, those data are to those AI models what food is to our human bodies, and we're made of what we've been eating and nothing else. And those models are made of the image we feed them and nothing else. And there's like a really high level of satisfaction in getting there. So when you try Autolume, you're gonna start thinking about data and data sets.
Yeah. And also in Autolume, I want to show where you can find, you can provide feedback if you want to. So there's a button on the top left that is a feedback where you will be sent to a Google form where you can either report an issue, either give us some feature request, or and I think there's multiple options, or report a bug, general feedback, feature request, report a bug or a problem. That's very useful to us if you find something that you can tell us here directly. There's a second button here for documentation. So wherever you are, we have like inline documentation like Michael demonstrated, but you can also access it here. And finally, I want to talk a little bit about Autolume data, because when you work by default, as Michael demonstrated, we have a default data folder. It will be normal here. I changed where it is because I have used a shared drive, but normally it goes into your user folder. It will be named Autolume, and we recommend you to use always whichever folder you like, but that when you use, for example, prepare or train, by default, it will be set to this pass dataset in this case, or training, it will be this pass to training runs, because that makes it so much easier to use the software in general. When you want to like resume something, you will get automatically all the previous runs that you had. If you want to open a model, then you will have automatically all the models that you have downloaded. Because if you download it in a separate folders and the user folder defined in Autolume, then you may have to click browse and have to look for it wherever you put it. So that's the folder. And also that folder can be preserved, meaning if you update Autolume to another version or you move, like you did a lot of work and you actually move to another computer, then you can just copy that folder and put it in the new Autolume folder in that machine, and all your work will be restored, including your models and whichever training runs you've had and dataset. So important to know about the Autolume the training folder. There's also a quick, if your screen for whatever reason, or if you need to see bigger fonts for yourself, then you can do that here. It's too small. Some screen it sometimes feels too small, so please you can change it here. And one thing that I would recommend is that if you ever get a crash with Autolume, sometimes you get a crash, maybe you run out of memory or something happens, you will get a little pop-up that says, do you want to report a crash? I would recommend please click send or always send, because that will help us a lot to figure out what bugs we may not find, because we're a small team, so it's very hard for us to test all the possible configuration that exist. And has been incredibly useful for us to send bug fixes specific to certain hardware or certain machines that we could not know otherwise about. And you don't have to do anything. It clicks. When you click, it just sends the logs of your machine. Doesn't send like personal information or anything. We don't collect anything like this. Just what went wrong in the software. Yeah, and that's pretty much it for me today.
Awesome, Lionel. Excellent. Thanks a lot. I just wanted to add one thing that is worth knowing as well is that Autolume is outputting when it runs in performance mode. It outputs an NDI stream of video. NDI is a network, another Ethernet protocol network device interface. And this one is to send actually frame accurate video streams. And so let's say you're a content creator and you want your background to be live Autolume stuff. Then you can stream to OBS before it streams to the internet, the image from Autolume. Or you can capture it in another software like Touch Designer and add effect and other control in real time. Or send it to a different computer that is plugged to a different projector, because maybe you're running 10 different projection of that particular image. So all of that is possible. And so on the input side, it's all control. On the input side, it's all controllable in real time, and also the output of the neural visual synthesizer is also like for any sort of synthesizer module, outputting continuous signal if you want it to. So that's another thing to know. And thanks a lot, Lionel. I'm going to proceed with a little conclusion here to wrap things up and before we say goodbye. So let's share slides one more time. And all right. So what we've been looking at today with Autolume and the little in the context of the introduction I was giving earlier is that a lot of big model in particular are made of questionable data. You don't really know, but often it's scrapped, and there's all sorts of legal pursuits out there. And then often you're only given the option to navigate, and often the only option to navigate you have is prompting, and often prompting only it gets you somewhere, but it usually doesn't get you where you want. So of course, there's also solutions that are more complicated, like Comfy and others that allows to adapt model and to craft model, and not only on existing data, but more interestingly for artists, often on curated data or even on your own data. And with Autolume, here you cover all that space where we feel that the more you have control over the data side of AI, and the more you're not just using someone's model, but you're adapting, personalizing a model, or even crafting a model from scratch, the more this is your work at the end. And so, without really going into generalities, we feel that there is something positive in terms of gaining creative control when we do that. And so Autolume covers and allows you to do quite all of the possible options on that graph. And so I hope you will get to try it for yourself. And to go back to the idea of small data, it's also interesting in the more general conversation around AI and this polarization I was talking about. There's a lot of AI haters, and for good reasons. But when you look at AI diversity, then you realize, well, with small data, we solve or avoid, most of the problems. Nothing's perfect, but you don't have to use stolen data. There doesn't need to be issues of plagiarism and consent. You can restore authenticity and authorship and maybe even revenue, and go around just prompting and gain copyright of what you create. There's potential for data and model sovereignties, as a lot of communities don't want, and a lot of artists don't want to upload their data set of lifelong work and their archive online. Trust is not always to be, cloud is not always to be trusted. And then the small data and model crafting, because it's then a practice, it has fantastic educational potential, therefore, and we're giving those workshops in a variety of contexts, and it really allows to take the means of production and develop your own AI by yourself, and therefore evidently increase control, understanding, and the proximity that you have between the model and your work and yourself. It also allows, as demonstrated by some of us in the room with the work, for example, of Arshia and calligraphy, to capture really cultural specificity and control the model bias, and maybe counteract on certain cultural data set, in a way, certain cultures and certain specific aesthetics not being represented because in other models because of data availability or because of bias. In fact, a lot of AI has a Western educated industrial sort of bias in the content that is being fed. And maybe that's a way to capture those cultural contents that are in the long tail of the data distribution. And maybe even to counter aesthetic homogenization, which is one of the things that general AI raise fears about. And indeed, it also addresses a number of other issues and meta issues, such as, for example, environmental cost, because small data is cheaper than big data. And as you see, you don't need the data center to run Autolume. And with Autolume, we're really proud of the work there, and it also sits really well within a more general context that is almost political of fighting and defending the idea of AI commons. The idea that AI doesn't have to be a corporate enterprise. In fact, it probably should be regulated a lot more. And as every government in the world right now, if only for security reasons, realizes there's a good to be able to make sure we can regulate and control it, it's a good idea that we make it public. And the internet was supposed to be the highway of information, and now it's almost entirely private. And for AI, it feels like the private and corporate has been taking over, but not all is lost. And there's a lot of there's a real movement towards AI comments that we feel we're being embracing here that will recognize AI diversity, promote AI literacy, and then facilitate international regulation and providing open source um, where we can inspect the code and make sure it's not malicious software and software stack. And so there's around the world like that, this movement. If you're interested in that, we've been working with art organizations across Canada, here in North America, and there's a report that came out late last year that I think is still very relevant with the group, the consortium Art AI, and it's about building commands for AI in digital creation, and it is quite an interesting read. And there's a lot of links and references if you're interested in that larger discourse in which we play a very small part. And so that's it for the workshop today. We really hopefully convey a sense that with those machines, it's not necessarily about replacing creators or replacing humans, but that we can really consider those machines as tools, and that sometimes they can even become interesting tools as long as we have control over them, and we get to design and use the type of AI that we want, as opposed to being forced. So with that, I want to thank all the lab members who were involved in one way or another. There's a lot more than I can name here. If you're interested in knowing more, there's also free classes on Cadence. I always like to give a shout out to Cadence, not just because I have classes there myself, but because there's a real need for more art and creative technology education that reach beyond the confine of the university and the ivory tower in where we sometimes sit. If you're interested in coming to the university, you don't have to be a master, PhD student, or a bachelor student. You can just be anyone and register to our courses online. We just opened 4 human-centered AI design and creativity courses at the School for Interactive Arts and Technology, available worldwide. And if you want to see us in person, we will be playing actually with Autolume in Korea in September, and then at Ars Electronica at the expanded conferences, then playing in China at Music Acoustica, and then being at AIMC, the AI Music Creativity Conference in Berlin. So that's September for those who will be in Europe. And we also want to thank our funding buddies here, the Canada Council for the Arts, the Social Science Humanities Research Council of Canada, and the National Science and Engineering Research Council of Canada, without whom that research and that work would not be possible. And I want to remind everyone, before I give it back to Lionel, that we have another workshop tomorrow and another Saturday. The workshop tomorrow will be Fragmentar, text to audio, model personalizations, LoRa's on a clean, stable audio base. And then on Saturday, model bending, which we learn how to do with GAN models today. We learn how to do that with diffusion models on Saturday. With Ahmed, we have a suite of objects there. Lionel, I see your hand.
Yes, we forgot to mention, but for training wise, we also, when you train in Autolume, you'll get energy and carbon receipt for how much energy was actually used by the training. So you can see for yourself and you can keep yourself accountable. And you actually, I will say, like, observe that the energy usage of this type of model, small model crafting models, is actually incredibly smaller than what you would think for like what is actually happening with big AI data. So for example, the Dahlia model used 55 kilowatt hours, and that's about 2.5 kilometers driven in a car in Canada. So like we don't even know the numbers, but that would be like probably like hundreds of kilometers for, or maybe a million for an actual stable diffusion model, for example.
Mm-hmm. Excellent. Yes, thanks, Lionel. Yeah, that's important to be able to track a little bit the carbon footprint of those technology. Excellent. So I want to thank all the presenters again today, Lionel, Arshia, and Michael, and then thank everyone for attending today. It's really good to have your attention. Yes?
I just wanted to mention, since it was asked in the chat a few times, we will release the workshop recordings publicly. You will probably receive an email next week, not immediately after workshop, but next week we will collect everything after the workshop series is done. The whole thing will be available through our YouTube channel, and you will receive the links.
Excellent. Thanks a lot, Asha. All right. Enjoy the rest of your day or of your night, wherever you are. And then for some of you, we'll see you tomorrow in the other workshop. Otherwise, we wish you well. And if you use Autolume, let us know. We always want to feature projects using Autolumes, and we could feature you on our website somewhere. Cheers. Bye now.
Bye, everyone.
Bye bye, everyone.
Thanks, everyone.